Okay, hello. So 5.2, the natural greenhouse effect. To start with, then we need to look at our solar insulation that is entering or reaching the surface of our atmosphere. So we have an electromagnetic spectrum, which is made up of these long wavelengths. Things like radio waves, microwaves, infrared, and then we have shorter wavelengths, things like UV, X-rays, and gamma rays. Now, most of the light reaching the Earth's surface is things like the shorter infrared wavelengths. We have visible light, and then we have UV radiation. We do have microwaves and radio waves reaching the Earth's atmosphere, but a lot of that sort of thing is interfered with our the electromagnetic field generated by the Earth's core, the magnetosphere. And X-rays and gamma rays are relatively damaging, and we don't get too many of them reaching us. So this radiation that reaches the Earth's surface, the atmosphere's surface on the edge of space. So we've got infrared, and it's the sort of near the visible um, end of the spectrum. We have visible light coming down, and we've got our UV radiation coming down as well. There we go. Now, the Earth's atmosphere has an ozone layer which is quite good at absorbing UV, so not too much of that gets through to the Earth's surface. What we find is that incoming solar radiation, let's say that is like 100%. So this is 100% of that incoming atmosphere. Incoming solar insulation at the surface of the atmosphere. Okay, so of that 100%, we find that actually 25% of it is reflected by clouds and dust and the atmosphere itself, so reflected. Okay, so that's 25. And then that carries on down, and we get 20% absorbed by the atmosphere. So things like the UV band of radiation by the ozone layer. That's 20. And we have another 5% of it reflected by the Earth surface. So Earth surface albedo. So this is how reflective the Earth's surface is. That's 5. So we have in total 30% is reflected solar radiation. Okay. Of this 50% that reaches the Earth's surface and is absorbed, what we find is that that is converted to heat. Okay, and that heat is emitted from the surface as a long wave infrared radiation. So we have 105% 1% is actually emitted. I'll explain why that's the case in a minute. And we have, this is absorbed by greenhouse gases. I'll abbreviate that to GHG, and that's things like CO2 and water vapor. And this causes atmospheric heating. And we have this coming across here, so that's absorbed by the atmosphere, is causing atmospheric heating. And we have 95% of it being reabsorbed. We then find that 60 of it is long wave infrared radiation emitted to space. And this emission of infrared radiation, we actually have it being emitted to space as well, and that makes up 10 there. So in total, we have 70 leaving the Earth's atmosphere. And we've also got conduction and convection within our atmosphere that transfers 30 around the place. Oh, so that doesn't go to that, that goes to up here. Okay. So the natural greenhouse effect is something that happens without any human interaction. It's been going on for a long time. So things like our incoming shortwave radiation is absorbed by the Earth, and then it is emitted as longer wave infrared radiation. And that's the important thing to remember, is it comes in as shorter wavelength of radiation and it's emitted as longer wavelength infrared radiation. So you have visible light, so short wave, infrared, so that's near visible, visible, and UV ultraviolet radiation coming in as short wave, and then we have our infrared, long wave infrared as our outgoing radiation, which is absorbed by the atmosphere and then reabsorbed by the Earth's surface or the atmosphere as well. If we did not have a natural greenhouse effect, we would be 33 degrees centigrade cooler as a planet. So if we didn't have a greenhouse effect, we would be much, much colder without it. So it's something we definitely need. And it controls lots of different things. This energy that we have coming from the sun being absorbed and re-emitted and reabsorbed is drives things like climate, ocean currents, the hydrological cycle, and a lot of these things are therefore the abartic factors that control the distribution of species. So it's a really important thing. And our greenhouse gases you will often see abbreviated to GHG. Things like CO2, water vapor is another really important one. Methane, and oxides of nitrogen, ozone, oxides of nitrogen. Okay, these are all really important gases that we need to know about. Okay, because they're the ones that absorb that re-emitted long wave radiation. But they are transparent to shorter wave radiation, so it can pass through them. Things like the visible and the UV and the shortwave infrared.